What are data mining basics for fraud detection? Imagine trying to find a needle in a haystack, but the needle keeps changing shape. That's what fraud detection is like without the right tools. Data mining helps us spot those hidden signs of fraud in huge piles of data. First, data mining involves collecting information from many sources. Think of transaction records, user logs, and financial documents. This raw data is often messy, so cleaning it up is the first step. We fix errors, fill in missing parts, and remove inconsistencies to make sure our analysis is accurate. Once the data is ready, we look for patterns. Classification is a key idea here. It means sorting data into categories like fraudulent or not fraudulent based on past examples. Clustering groups similar data points together, helping us find unusual clusters that might show suspicious activity. Association rules help us discover relationships, such as certain transactions happening together often, which could point to fraud. Supervised learning uses labeled data to teach models what fraud looks like. For example, if we know certain transactions are fraudulent, the model learns to spot similar cases. Unsupervised learning, on the other hand, finds anomalies without prior labels. This is useful when fraud tactics change or are not well understood yet. Feature engineering involves choosing and transforming data attributes that signal fraud. For example, the amount of money, the time of transaction, or the location. Good features make models more accurate. Data preprocessing cleans and prepares data, making sure the models get the best possible input. Common techniques include decision trees, which make simple yes or no decisions based on rules. Neural networks can learn complex patterns, like how a fraudster might disguise their actions. Bayesian networks estimate the probability of fraud based on observed data. Support vector machines find the best boundary between legitimate and fraudulent data points, especially when patterns are not clear-cut. Logistic regression calculates the chance a transaction is fraudulent, giving a score to help prioritize investigations. The process starts with gathering data from different sources, then cleaning and preparing it. Next, we select the most relevant features. We train models using known examples of fraud and test how well they perform. Once the model is ready, it scores new transactions, flagging suspicious ones for review. Human experts then check these flagged cases to confirm if fraud is happening and decide what action to take. One challenge is that fraud cases are rare compared to normal transactions, making it hard for models to learn effectively. Ensuring data quality is also vital, as poor data can lead to false alarms or missed frauds. Fraud tactics are always changing, so models need regular updates to stay effective. From an artificial intelligence perspective, data mining for fraud detection uses models that learn from past data to spot complex patterns automatically. Tools like neural networks and support vector machines are common here. AI productivity tools, like language models or image generators, share similar principles of pattern recognition and learning from data. These tools can help fraud analysts by automating report creation or summarizing findings, making their work faster and more accurate. Understanding these basics helps us see how data mining plays a vital role in keeping financial systems safe and trustworthy.